This video shows thin layer chromatography of Streptomyces venezuelae extracts. We do the chromatography in the fume hood. We are using 9 parts chloroform to 1 part methanol as our solvent. We pour the solvent into the chromatography tank to a depth of about 1 centimeter. We pour a thin layer of iodine crystals into the bottom of the other tank to stain our TLC plates. The TLC plates are plastic with a thin layer of silica on one side. The shiny side is plastic, the dull side is the silica. Using a ruler, we mark a straight line about 1 centimeter from the bottom of the silica plate. We then mark the positions of our 7 samples. We will be using 4 chloramphenicol standards and 3 extracts from our Streptomyces venezuelae. A 25 milligrams per mil chloramphenicol standard, a 5 milligrams per mil chloramphenicol standard, WT for our wild type Streptomyces venezuelae extract, M for M1582, plus for our positive control, 1 for our 1 milligram per mil chloramphenicol standard, and 0.2 for our 0.2 milligram per mil standard. We first spot our bacterial extracts onto the TLC plate. We spot 10 microliters of each extract onto the plate, doing 3 times 3.3 microliters for each extract, allowing the spots to dry between each application. Each application is spread out over 3 positions to make a nice wide band. Now that the first 3.3 microliters is complete, we can start again on the next 3.3 microliters. A final set completes the bacterial extracts. Ten microliters of each chloramphenicol standard is plated in exactly the same way. We can see where the samples have been loaded at the bottom of the TLC plate. Each TLC plate is placed in the chromatography tank, with the bottom immersed in the solvent. It takes about 30 minutes for the solvent to migrate to the top of the TLC plate. Compounds in our samples are carried upwards through the TLC plate by the movement of the solvent, or mobile phase. Polar compounds move more slowly than nonpolar compounds. When the solvent front has moved to within a few centimeters of the top of the plate, we remove it from the tank and mark the position of the solvent front. Plates are allowed to dry in the fume hood. We can already observe migration of colored compounds in our bacterial extracts. Some colored compounds have not moved at all, whereas others have moved all the way to the top of the solvent front. We cannot yet see any chloramphenicol on our TLC plates. Many organic compounds stain well with iodine. We'll therefore stain our plates with iodine. We place them in the tank with the iodine crystals and leave them for about 10 minutes. Once done, we remove them and we see orange staining on the plates. Some compounds in our bacterial extracts stain well with iodine. However, these are not chloramphenicol because no chloramphenicol is visible in our standards. We will next try a ninhydrin stain. We spray the TLC plate with ninhydrin and then place it in an 80-degree oven for 10 minutes. Ninhydrin stains amines and amides. After 10 minutes, we can remove our TLC plates from the 80-degree oven. We can see chloramphenicol by ninhydrin staining in our chloramphenicol standards and in our M1582 extract, as well as our positive control.